Is everything okay now?
Yes, sir.
Yes, sir.
So now coming to the turboprop, the total thrust power is equal to shaft power into propulsive efficiency plus thrust into velocity. This is jet thrust. This is shaft thrust or propeller thrust. So usually propeller thrust will be around 60 to 70%. This is more than the jet thrust. So as you go for turbofan and all, jet thrust will increase. That's why. Okay, the propeller thrust is very large. And here, so there is another power defined that is called as effective power. So what is the effective power is equal to thrust power by propeller efficiency, which is equal, because they don't want to see the propeller efficiency affecting much. Shaft power is large. So what they have done is like this. Like this. Okay, because this is the main power and this is the small power FCA. So they found this is more effective equation than using the thrust power. So effective power is used. Okay, this is for turbo prop. And another thing is called as turbo shaft. Turbo shaft. So here there will not be any jet thrust used. There is only propeller thrust. Thrust power is only shaft power into propeller efficiency. No jet thrust. Do you know where is it used? This is used in helicopters. Helicopter rotor is run with gas turbine. Like this, if you see a figure, something like this. Okay, this is helicopter engine like this. So here also, because helicopter propeller also is very large, okay, this is run with a gear again, so that the speeds will be less. These are called turbo shaft engines. Okay, there is one more concept called as thrust augmentation. Okay, this is very important. In industrial gas turbines, as I told, industrial power plants, okay? So in power plants, so there will be normal power and peak power. Okay. So as I told, sometimes there will be peak timings where I need additional power, some more power. But if I design the gas turbine to this peak power, during normal power generation, the efficiency will fall down. So I want some additional power during peak power. So for that, we will have some auxiliary power system. Auxiliary power, as I told, Codad, the co-gas, co-gas like that. There will be gas and steam, gas and diesel, diesel and diesel like that. For main power, there will be one engine, and for auxiliary power, there will be another engine. And whenever I need higher power, I switch on the auxiliary power. So that is the way we do. In the same way, here the turbojet or aircraft, I can say, not turbojet. So aircraft, 95% of the time, it runs at constant speed. This is called as cruising speed. But there are times when there is takeoff or acceleration or climb. Okay, so like that, if it wants to go at a higher speed, or if it has to go to a higher altitude, or it has to take off, those times it needs higher power. But if I design for this, because I know that gas turbine efficiency is very less in off design conditions. So what to do? If I design at these conditions, my efficiency throughout will be less. But if I don't take care of this, how to do it? How to take off it all first? So there are what are called as thrust augmentation techniques. So if I want to augment means increase. Okay. So there are one way is to increase mass flow or to increase jet velocity, because thrust power is equal to FCA or m dot Cj minus Ca into Ca. So either by increasing the mass flow or by increasing the jet velocity, right, I can increase the thrust power. But it should be only for small duration, I should be able to do that. Okay, so for that, what are the methods? There are two methods. One is injecting of fluid to increase the mass flow. So what we do is water injection at the inlet of compressor. So at the inlet of the compressor, I inject some water. So what happens? It gets evaporated, cools the air, reduces compressor work, increases net work, or reduces compressor work means, okay, increases net thrust. And also increases mass flow. Okay, there will be increase in the mass flow and also jet velocity, because compressor work needed is less. So the turbine, from the turbine, it takes less work, and because of that, there will be more power for the nozzle. Is this clear?
So the thrust increases, but how the mass flow is increased?
Because I am injecting some water, additional water.
Yes, yes. Okay, sir.
Okay, so this is one. Or sometimes water plus methanol is injected. Okay, so this methanol, it burns in the combustion chamber. So there will be additional thrust. Okay, and so sometimes the mixer can be injected in the directly in the combustion chamber. So this also can be done directly. It can be injected into the combustion chamber, and the methanol burns, water increases the total mass flow and all. Okay, this is one method, injection of fluid either at the inlet of the compressor or within the combustion chamber. And the second method is what is called as afterburning, or sometimes called as jet pipe burning. Okay, so when I have like this, turbine, so here this is called jet pipe. Okay, here I can inject some more fuel after the turbine because air fuel ratios are high. Okay, unused oxygen will be still present. So I can burn some more fuel. So I can inject the fuel in the jet pipe so that I can increase the temperature or the enthalpy so that I will have increase in the thrust power. Is it clear? The advantage is so after this is turbine, compressor, combustion chamber. And here, after the turbine, instead of expanding here to the nozzle, it is temperature is increased like this. And so this will be the thrust. This is the nozzle power I will get. So the advantage, suppose this is 1200 Kelvin because of metallurgical limit. In the jet pipe, there is no metallurgical limit. For turbine blades, I have metallurgical limit. So I don't have metallurgical limit. I can go up to 2000 Kelvin. Am I clear? Am I clear about this?
Yes, sir.
Yeah.
Yes, sir.
So that is the advantage of afterburning. So here, whenever it needs some additional power, so it injects some fuel in the jet pipe. So there will be additional thrust. And once that is over, I can stop the fuel supply into the jet pipe. Okay, that is the way I can have. So this is, and this is also called as and sometimes this is called as sorry, turbo ramjet. This is called as turbo ramjet. What is ramjet? It is only just burning the fuel, right? At the end. So here, this is like ramjet, adding ramjet to the turbojet like that. Okay. So sometimes this is called as turbo ramjet. A turbojet with afterburning or jet pipe burning. Okay, this is what I like to tell. So spraying water into the compressor inlet or spraying mixture of water and methanol either into the compressor inlet or directly into the combustion chamber, and after burning or reheat. So this is the way we will have. So due to the after burning, I will have so much of thrust. So here it is only this much, and so because these are diverging, right? These are diverging. So here there will be more. Okay, that is about, and actually I wanted to show some videos. I have to see how I have to do about it. Okay, just. I think to share videos, I have to share tab. Huh? will see whether you can. So one turbofan animation I like to show. See whether if you are not listening to the audio, I have to share tab.
When Boeing decided to take the world's most popular jumbo widebody to the next level, they wanted the most advanced engine technology.
Can you listen to the audio?
Yes, sir.
Yes, sir.
Okay, no problem then. Okay.
Available. The GE NX2B was the perfect solution. A derivative design, this engine uses the same high-pressure system as the GE NX that powers the Boeing 787, while incorporating an optimized low-pressure system designed specifically for the 747-8. The high-pressure system, or core, features a compressor that is the most compact and efficient GE has ever produced. With just 10 stages, this compressor delivers our highest pressure ratio with the same stall-free operation you expect from GE. The surrounding case stays concentric, so clearances remain tight, improving overall performance. Combined with durability enhancements, this compressor won't need an overhaul until the second shop visit. Another integral feature of the GE NX core is the low-emissions TAPS combustor. This design pre-mixes fuel and air, resulting in lean burn combustion and more uniform flame temperatures. As a result, emissions are dramatically lowered, and distress on the liner and downstream components is reduced. While the flame profile exiting the combustor is more consistent, the high-pressure turbine still handles the most extreme temperatures and pressures in the engine. To make the most of this energy, GE has combined advanced design codes with our latest cooling techniques to enable fewer blades to do more work while also maximizing component life. It's the careful balance of performance and durability throughout which have combined to make this core our best ever. The low-pressure system of the GE NX2B is designed with a smaller fan, fewer stages, and lower weight to precisely match the needs of the four-engine 747-8. The fan module uses aviation's only composite fan blades and fan case to create a lightweight and durable module that is virtually maintenance-free. This innovation has been proven for more than a decade with the GE90 fan blades. As with many components in the GE NX, the booster incorporates the latest 3D aerodynamic improvements, as well as a debris rejecting system to keep foreign material from entering the compressor. The low-pressure turbine is an ultra-high lift design. This long-life, high-performance module rotates counter to the core, further improving efficiency and reducing the total number of parts used. Unique to GE is a modular design that enables the engine to be split into two parts, the fan and the propulsor. When maintenance is required, the propulsor can be removed easily and replaced with a spare. This translates to a lower spare engine investment and greater flexibility in transportation. And with many common components to other GE NX engines, customers with mixed fleets can realize operational, maintenance, and provisioning synergies. This engine will also benefit from the GE NX family testing and maturation program that is the most extensive in our history. The GE NX2B delivers dramatic improvements in fuel efficiency with significantly lower emissions. Its reduced carbon and noise footprints mean greater access and lower landing fees, giving customers a competitive advantage for years to come.
Okay, just to show the turbofan working, and we will see some more things like
The next generation of long-range aircraft are currently in development. To power them, GE is creating the most advanced commercial turbofan in our history.
some other things. I think next class we will go for compressors. I will show you how a centrifugal compressor And these are various compressors like vane compressor and lobe compressor, 2 lobes, and that is gear pump like this. 2 lobe compressor, 5 lobe compressor, that is those things. Axial compressor, centrifugal compressor. Okay, I will show you how a centrifugal compressor.
In large manufacturing facilities and process industries, Ingersoll Rand has long been a trusted partner for oil-free centrifugal air solutions. Since the introduction of our first Centac packaged centrifugal air compressor in 1968, Ingersoll Rand has been known for simplicity by design. Simplicity by design led to the reduction of moving parts and integration of major components, which quickly made Centac known as the most reliable oil-free compressor in the world. Simplicity by design also spurred industry-changing innovations, such as backward-leaning impeller vanes to improve operational range and efficiency, and carbon ring seal designs to minimize air loss. More than 40 years of simplicity by design have made Centac the most dependable, lowest operating cost centrifugal solution available, with more than 20,000 units installed worldwide. Our all-new Centac Model C1000 continues the tradition, with more than 50 design improvements to maximize reliability, efficiency, and productivity. Air enters the package through an inlet air filter. The inlet valve or inlet guide vanes regulate the air entering the compressor. At the heart of the compressor is a key Ingersoll Rand advantage, a rotating assembly consisting of the impeller mounted to a pinion gear through Ingersoll
You have to
Rand's
see how a
revolutionary
impeller looks like.
tinted polygon attachment. The attachment's precision fit and polygon shape lock the impeller and pinion together in 3 dimensions for a precise and sturdy connection. No unusual tools or pressure are needed when working on a rotating assembly, allowing for quick and easy field maintenance. Our signature backward-leaning impellers help maximize the efficiency and turndown of the C1000. Designed with leading-edge software and precision crafted from high-grade stainless steel, the C1000 impellers are built to withstand even the harshest environments. The rotating assembly is driven by an extremely durable bull gear. This robust, precision-ground, agglomerated bull gear has been through-hardened to maximize life up to 25 years. It's connected to the motor via a flexible gear or dry-type, maintenance-free coupling. The low-speed bull gear bearings add to the durability, since no thrust is transferred to the bull gear shaft. The assembly rides on a thin film of oil separated from the air by non-wearing carbon ring seals, ensuring 100% oil-free ISO Class 0 air in all operations.
Okay, I want to show you the animation. Mhm.
Every screw means or stay helical. Compression is achieved by the meshing of 2 helical ropes.
Actually, I didn't put that. Couldn't that. Okay, just because I want to show how the veins look like. Okay, so radial veins. So these are radial veins. You can see at the end and the tips it's almost radial. Previously it is bent like this. They are backward curved veins. And here these are called inlet guide veins. There are 3 parts will be there. One is inlet guide vein, and then there is impeller, and after the impeller there will be diffuser. So you can see that diffuser also. So these are diffuser veins. Okay, this can be changed its angle if you want. Okay, so inlet guide veins, impeller, and diffuser veins will be there. So these things I wanted to show you because next class I am going to discuss about these things. And as I told, these are radial veins, and if they are bent, as I have shown in the previous one, they are backward curved veins.
Designed with leading-edge software and precision crafted from high-grade stainless steel, the C1000.
And there can be forward curved veins also, but normally we don't use them. And next, another thing. Okay, another thing I wanted to discuss before leaving the aircraft propulsion, right? So how aircraft maneuvers. Okay, how it gets maneuvered, that is how it takes turns or anything. Okay, you understand how it is taking off because of the lift from the air, this and all. Even then, actually the aircraft, if I take this aircraft, there are four forces will be acting. One is upward force and downward force. This is weight, and this is thrust, sorry, lift. This is lift. And so here there will be drag this way, and there will be thrust. Okay, these are the two forces will be acting. So the lift has to compensate weight, and if you increase the lift and it goes to a higher height. Otherwise, increasing lift and weight will be same. In the same way, the drag and thrust. So depending on how much thrust is more than drag, its forward velocity will increase. So these are the main things that will be working. And so all these lift and drag, it is because of aerofoil. Okay, so the wings are of having aerofoil shape, and it has a force because of the forward velocity of the air, and there will be components, lift force and drag force. One is in the direction of, this is drag thrust, okay, in the direction of flow. So lift is normal to the direction of flow. Okay, up to this it's okay, all people understand. Now how it takes maneuvering. Maneuvering means what are the types of motions will be there? Okay, maneuvering. So there are, do you know what is maneuvering? The turning of the aircraft or moving the aircraft in different directions. So here, if I take like this, and this is the longitudinal axis, and this is the transverse axis. And okay, perpendicular to the board, okay, there will be vertical axis to go up and down. Okay, and now there are turning moments. Okay, so if it turns about the transverse axis, that is nose up or nose down. Okay, what is that motion is called? Anybody knows?
Pitching.
Pitching.
Rolling.
Right.
Pitching.
Pitching. Nose up or down is pitching. Okay, which is rolling?
About longitudinal
About
axis.
the long.
Turning around longitudinal axis. This is rolling. And moment about vertical axis?
Yawing.
Yeah. This is yawing. That is turning to right or left. Okay, how it gets these motions? Anybody knows?
Gyroscope. They manipulate the flaps of the wings.
Yeah. Where are the flaps?
On the wings, sir. Both sides.
Yeah. Actually, not on both. Okay, both sides will be there. Okay, here, this is split like this. The wings are split like this, and these are called ailerons. Ailerons. And about this point, this line, it can be turned down or up. And in the same way, these are tail wings. These are also split into like this. So these are called as elevators. And there will be a vertical wing also will be there, a vertical one. Okay. And that is also split into, so if it is like this, okay, so a part of it can be shifted this way or this way. And that is called as rudder. So these are all controls, right? Ailerons, elevators, and rudder. These are aircraft controls. Okay, which defines the turning or anything. So now, which movement is obtained by controlling what? Okay, if I want yawing to turn left or right, which is to be controlled?
Elevators, sir?
Which one? No,
I guess rudder, sir.
the
Rudder.
name itself says elevator. Elevator is to go up or down.
Rudder, sir?
Rudder, yeah. Like a ship, no? If you want to turn this way or that way, rudder is to be used. Okay, so rudder, how it is vertical one. In the vertical one, a part of it is shifted. Suppose it is moving like this. Aircraft is moving this way. Okay, it is at the end of the aircraft, it is like this. And suppose a part of it is shifted like this. So what happens? The air coming in this way, it pushes this side. So tail goes to this side and nose turned that side. Is it clear? If I turn it to the right, nose turns left and tail turns left and nose turns right. So whichever way it turns, the nose takes the same direction. Am I clear about it?
Yes, sir.
So
Yes,
that is the way yawing is done by rudder. And the elevator, okay, elevator, it is at the tail end. Okay, in the tail end, if I shift it down like this, what happens? Air coming like this, it pushes this up. Because if I turn it down, okay, it pushes it up. So when nose goes up and tail goes up and nose goes down. Is it clear? So if elevator is down, nose goes down. If elevator is up, nose goes up. Okay, so for takeoff, you take the elevator up. And for landing, you take the elevator down. That is the way the pitching action is taken. Am I clear?
Yes, sir.
Yes, sir.
In the same way, rolling ailerons we move. Okay, elevators for pitching and rudder for yawing and ailerons for rolling. Okay, what it will do? On the left side, one aileron is there, right side, one aileron is there. On the left side aileron, suppose if I push it down, so what happens? So this lift increases, it goes up, right? Because air coming it pushes up. So left one, right one, suppose if I bring it right down, so right wing goes up. And opposite way I will do in the left side. So it goes down. So it will take rolling action in this way. Opposite way, it goes that way. Like that, I can have rolling action. One side, I will increase the lift. Another side, I will decrease the lift. Am I clear?
Yes, sir.
Okay, that is the way rolling is done. And sometimes a combination of this will be done. Suppose if it is taking yawing, when it's taking turning, actually it has to bank. So a little bit of rolling also is needed. Like road banking is there, right? So in the road turning, so there will be some banking will be there so that it won't fall. Am I right? So in this way, yawing and rolling usually be together. So rudder and ailerons both together are to be operated when it's taking yawing turn. Okay, this is the way the maneuvering is done. Is it clear? So I will show you time is there. Just 5 minutes. I will show you on video. Aircraft flight controls. Flight control.
episode you watched in the Christian of majestic aeronautical majesty. You can do this by visiting my YouTube channel page or the Prof Pilot blog. Alternatively, you can try and brave this all by itself, cold, and episodes 1 does itself using its primary flight controls. These are the ailerons on the wings, the elevator on the horizontal stabilizer, and the rudder on the vertical stabilizer. You can pretty much think of all of these controls as airfoils like this, which you might remember from the last episode. This can be the aileron, or
So actually, by bending that small piece down, I am increasing the curvature. By increasing the curvature, or I increase the angle of attack. Any of them, that is camber line, increase the angle of the camber line, or increase the angle of attack, there will be increase in the lift. Okay.
elevator, or rudder, and when it moves, it alters the angle of attack, and therefore lift, of the control surface, moving the aircraft in the desired direction. Let me show you what I mean. An aircraft controls itself in roll using its ailerons, and you control this using the yoke in the cockpit. To roll left, you would move the yoke left, and this will cause the left aileron to move upwards, and the right aileron to move downwards. From the last video, you should remember that an aileron moving upwards decreases the angle of attack, and this will reduce the lift generated by the left wing. On the right wing, the aileron moves down, which increases the angle of attack, increasing the lift on the right wing. This imbalance of lift will cause the aircraft to roll to the left. Rolling to the right just reverses everything. Keep the yoke right, and the left aileron goes down, which increases angle of attack and lift on the left wing. The right aileron goes up, which decreases the angle of attack and lift on the right wing. So the aircraft will roll to the right. Next, we will look at the elevator. In this picture, we are looking at the aircraft from the side. Here are the ailerons, and here is the elevator, and again, the yoke. To climb, you will pull the yoke backwards, which will move the elevator upwards. Looking at our friendly airfoil, we can see that this has the effect of decreasing the angle of attack so much that it actually causes lift to act downwards. This will push the tail down and move the nose up, causing the aircraft to climb. To descend, you will push the yoke forwards, the elevator will move down, the angle of attack at the tail will increase, and this has the effect of increasing the lift at the tail. The tail will be lifted, which will push down the nose, and the aircraft will descend. Finally, the rudder. Looking at the aircraft from above, you can think of the combination of the vertical stabilizer and rudder like a vertical wing. You control the rudder using the rudder pedals, or ruddles, which you operate using your feet. These are usually found in the cockpit and not floating 6 feet to the right of the aircraft, as they are in this picture. Push the right pedal, and the rudder will move right. This will cause lift to act on the horizontal stabilizer in this direction, which will pull the tail over here. This yaws the aircraft to the right. If you push the left rudder pedal, the rudder will move left. Lift then pulls the tail over this way, and the movement of the tail causes the aircraft to yaw in the desired direction. You can also have different setups with the primary flight controls where one surface can combine 2 of the above. A good example of this is Concorde, the finest aircraft ever constructed, mainly because it was British. You can see it has no horizontal stabilizer, so there is nowhere for an elevator. It controls itself in pitch and in roll, using these elevons, which combine the functions of the elevator and the ailerons into one set of flight controls. They work by moving up and down together, like an elevator, for pitch control, or in opposite directions, to control and roll. Similarly, you can get a V-tail, like this Beechcraft Bonanza, which combines the elevator and the rudder. That's it for now. See you next time when we will cover the fascinating subject of secondary flight controls.
Is it clear how the maneuvering is done?
Yes, sir.
Yeah, I will send if you want these videos, whatever I have shown. This gives a very small video, but it gives complete understanding of how this controls and works. Okay, Any questions? Any questions?
No, sir.
I think, shall we have 5 more minutes? We will have the story.
Yes, sir.
Yes, sir.
Okay, we will have the story. So it is a recently I came across this story, and she is a collector. Now still she is there, Rani Soyamoi, and she goes to a school, and he talks with the kids there, and she is very simple, very simple, right, down to earth, and so why is the collector not wearing makeup? So Malapuram district collector Srimati Rani Soyamoi interacts with college students. She wore no jewelry other than a wristwatch. What surprised most of the children was that she did not even use face powder. The speech is in English. She spoke for only a minute or two, but her words were full of determination. The children then asked the collector some questions. What's your name? My name is Rani Soyamoi. Soyamoi is my family name. I am a native of Jharkhand. Anything else to ask? A slender girl stood up from the audience, asked side, Madam, why don't you use any makeup on your face? The collector's face suddenly turned pale. Sweat broke out on her thin forehead. The smile on her face faded. The audience suddenly became silent. She opened the water bottle on the table and drank a little. Then she gestured to the little child to sit. Then she began to speak slowly. The child asked a confusing question. It is something that can never be answered in a single word. I have to tell you my life story in answer. Let me know if you are willing to set aside your precious 10 minutes for my story. Ready? She tells, I was born in a tribal area of Jharkhand. The collector paused and looked at the audience. I was born in a small hut in the tribal area of a Kodarma district full of mica mines. My father and mother were miners. I had two brothers above and a sister below. We lived in a small hut that leaked when it rained. My parents worked in the mines for a meager wages because they could not find another job. It was a very messy job. When I was 4 years old, my father, mother, and two brothers were bedridden with various ailments. Little did they know at that time that the disease was caused by inhaling the deadly mica dust in the mines. When I was 5, my brothers died of an illness. With a small sigh, the collector stopped talking and closed her eyes filled with tears. Most days, our diet consisted of water and 1 or 2 loaves of bread. Both my brothers left this world due to acute illness and starvation. In my village, there were no people who went to the doctor or to school. Can you imagine a village without a school, a hospital, or even a toilet, even without electricity? One day, when I was hungry, my father grabbed me, all skin and bones, and dragged me to a large mine covered with corrugated iron sheets. It was a mica mine that had gained notoriety over time. It is an ancient mine that was dug up and dug into the underworld. My job was to crawl through the tiny caves at the bottom and collect mica ores. It was only possible for children under the age of 10. And for the first time in my life, I ate bread and a half full stomach. But that day I vomited. By the time I was in first grade, I was sniffing mica through the dark rooms where I could breathe poisonous dust. It was not uncommon for unfortunate children to die in occasional landslides, and occasionally some with fatal diseases. If you work 8 hours a day, you will earn at least one loaf of bread. It was thin and dehydrated every day because of hunger and starvation. A year later, my sister also started going to work in the mine. As soon as I got a little better, my father, mother, sister, and I worked together and came to a point where we could live without hunger. But fate was beginning to haunt in another form. One day, when I was not going to work due to high fever, it suddenly rained. Hundreds of people died when the mine collapsed in front of workers at the base of the mine. Among them were my father, mother, and sister. Tears began to flow through both eyes of the collector. Everyone in the audience forgot even to breathe. The eyes of many were filled with tears. I have to remember that I was only 6 years old. Eventually, I arrived at the government Agati Mandir, where I was educated. I was the first from my village to learn the alphabet. Finally, here is the collector in front of you. You may be wondering what is the connection between this and the fact that I do not use makeup. She continued, glancing through the audience. It was then I realized that the whole mica I had collected while crawling through the darkness those days was being used on makeup products. Mica is the first type of fluorescent silicate mineral. Among the mineral makeups offered by many big cosmetic companies, the most colorful are multicolored mica that make your skin glow with the lives of 20,000 young children at the risk of their own lives. The softness of the rose spreads on your cheeks with their charred dreams, their shattered lives, and their flesh and blood crushed among the rocks. Millions of dollars worth of mica are still picked up by baby hands from mines to enhance our beauty. Now you tell me, how do I apply makeup on my face? How can I eat on a full stomach in memory of my brothers who died of starvation? How can I wear expensive silk dresses in the memory of my mother who always wore torn clothes? The whole audience stood up unknowingly as she walked out, holding her head up without opening her mouth, filled with a small smile. The makeup on their faces was starting to soak in the hot tears that were dripping from their eyes. Don't blame them if some of them are disgusted when they see women full of face powder, cream, and lipstick. The high quality mica is still mined in Jharkhand. More than 20,000 young children work there without going to school. Some are buried by landslides and some by disease. Okay, thank you. It's really touched me, and just I wanted to share. And she is that. Okay, later some uh, news came that it's a fake story or something like that. Whatever it is, whatever is happening is truth. Whether her life story is completely right or not, I don't know. But what is happening is real truth. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, sir.
Thank you. Thank you.
Thank you, sir.
Thank you. Thank you, Dipanshu.
Thank you, sir.